Hello, Math 151. Up to now, we learned how to find the derivative of a function. And now the natural question to ask is, what if I knew the derivative of a function and I wanted to know what the function itself is? Could I do that? And the answer is yes. So we have a theorem that if capital F is an antiderivative of small case f on an interval I, then the most general antiderivative of f is capital F of x plus c, where c is an arbitrary constant. So for something as simple as, let's say, f of x equals some x to the power of n, if f of x equals x to the n, then capital F of x, which is antiderivative of small case f, equals x to the power of n plus 1. So we add 1 to the power and divide by the n plus 1 plus some constant c, where n cannot equal -1. Well, we do have a different rule for when n equals -1, but it's not part of this video. So here's an example. Suppose f of x, small case of x, equals x to the second. So the antiderivative of that, capital F of x, equals x to the third power divided by 3 plus c. Let's do some examples. Suppose if I have f of x equals x just to the, say, power of 1, and let's say I have a -3 here. And you can think of this, you can think of this as f of x equals x minus 3x to the power of 0. So what is capital F of x? What is the antiderivative of the function? We said that, for my original one, notice that the power of x is only 1. So I'm going to have to say, here's my x, adding 1 to the power gives me a 2. Divided by 2, minus 3 is my constant. I'm going to keep it. So here's my x, adding 1 to the 0 gives me a 1, and divide that by the power, now that my new power, which is 1. So plus some constant c. So now I know that f of x equals 1/2 of x squared minus 3x plus some constant c. Okay, well, now that I know that capital F of x is the antiderivative of small case f, it makes sense for me that if I take the derivative of my capital F of x, I should get my original function back. So let's do that. So if I take the derivative of f of x, I should get my original small case f of x back. 2 times 1/2 is 1 times x, subtract 1 from the power, so I get a 1. Derivative of -3x is -3, and derivative of any constant is 0. So as you can see, I have my original function back. You can always and all the time test yourself to make sure that you've done this right. Let's do another one. Suppose small case of f of x equals 1/2, say, x to the second minus 2x plus 6. And we want to find the antiderivative capital F of x equal. Well, here's my 1/2. That's my constant. I'm going to leave it. So x to the power, I had x to the power of 2. If I add 1 to it, then I have x to the power of 3. Now I can divide by 3, but it's better for me to multiply by 1/3, which is the same thing as dividing by 3. It's just a little bit cleaner. Minus, here's my 2, x to the power of 2. Instead of dividing by 2, I'm going to write multiply by 1/2. Plus, notice that, remember that we said you can think of this as 6x to the power of 0. So 6, okay, x to the power of 1, and dividing it by 1, or multiplying by 1 is the same thing. So I'm going to just put a 1 just for the sake of discussion. And we have a plus c. So let's clean this up. So f of x equals 3 times 1/2 is 3/2. Oh, no, sorry about that. 1/2 times 1/3 is 1/6. Getting ahead of myself. 1/6 x cubed minus -2 times 1/2 is just -1 x to the second power plus 6x plus c. So now I'm going to test myself. So test. If I take the derivative of the capital F of x, I should get my original function back. So f of x equals derivative of 1/6 x cubed is going to be 1/2 x to the second. Derivative of minus x squared is minus 2x. Derivative of 6x is plus 6, and derivative of c is just 0. So yes, we did this correctly. So here's it, and naturally you probably think that what's the deal with c? Why do we keep adding a c here? And here's the reason. Suppose at some point you had some g of x equals, let's say, x squared, and f of x equals x squared plus 1, and let's say h of x equals x squared. Let me give myself a little bit more room here. And h of x equals x squared minus 10. Remember that if I take the derivative of all these three, so g prime of x equals 2x, and f prime of x equals 2x, and h prime of x equals 2x. So when we do take the derivative, we lose and think of the first one as x squared plus 0. So like your y-intercept is 0, okay? So notice that when we take the derivative, we lose the initial value, or better to say the y-intercept, we lose that. So that's why when we take the antiderivative, we add a plus c, So, and then how can we find what that c is? We are going to have some initial condition, which is not part of this video. In this video, we just want to practice taking some very basic antiderivatives. Let's do a couple more, and then suppose I have f of x equals 1/2 plus 3/4 x to the second minus 4/5 cubed. Okay. And remember that we said that you can think of this 1/2 as 1/2 x to the power of 0. X to the power of 0 is 1. 1 times 1/2 is 1/2. So now the capital F of x antiderivative, here's my 1/2 x to the power of add 1. And then I have to divide by that 1, which I'm not going to do because it doesn't make a difference. Plus 3/4 x, add 1. And then instead of dividing by 3, I'm going to multiply by 1/3 minus 4/5 x to the power of 4 times 1/4 plus some constant c. So f of x equals 1/2 x plus 1/3 times 3/4 is just 1/4 x cubed minus 1/5 x to the power of 4 plus some c. So one last time, let me test to see. I mean, we are done in here. We did, we're done, but we just want to know that we want to test. So to test to see if we did correctly, I'm going to take the derivative of capital F of x to see if I get f of x back. Derivative of 1/2 of x is 1/2. The derivative of 1/4 x cubed is 3/4 x to the second. The derivative of negative 1/5 x to the fourth is minus 4/5 x to the power of 3, and the derivative of any constant is 0. So yes, we did, we took the antiderivative correctly. And let's do one last one. Suppose we have small case of f of x equals 8x to the power of 9 minus 3x to the power of 6 plus 12x to the power of 3. And we want to take capital F of x, the antiderivative. Here's my 8. So x to the power of 10 times 1/10 minus 3x to the power of 7 times 1/7 plus 12x to the power of 4 times 1/4 plus some constant c. So f of x equals 8/10 is the same as 4/5 of x to the power of 10 minus 3/7 of x to the power of 7 plus 3x to the power of 4 plus c. And let's test one last time. Just test to see. I'm going to take the derivative of capital F of x to see if I get f of x back. 10 times 4/5 is 8x to the power of 9, so that's correct, minus derivative of 3/7 x to the 7th is going to be 3x to the power of 6 plus 12x to the power of 3, and derivative of c is derivative of any constant is 0. So yes, we did good. Okay, well, I hope you like these examples. Thank you.